Dear students, welcome to Study and Learn Academy. I am Dr. Ganapat Nagda, and today we will discuss a common topic of the chemistry, that is the mole and Avogadro's constant. The mole. This is the mass of a substance containing the same number of fundamental units as there are atoms in exactly 12.000 gram of carbon atom. The mole is the unit representing the amount of atoms, ions or molecules. 1 mole is the amount of substance that contains 6.02 into 10 to power 23 particles in the form of atoms, molecules or formulae of a substance. 6.02 into 10 to power 23 is known as the Avogadro constant number. Example, 1 mole of sodium contains 6.02 into 10 to power 23 atoms of sodium. 1 mole of hydrogen H2 contains 6.02 into 10 to power 23 molecules of hydrogen. 1 mole of sodium chloride NaCl contains 6.02 into 10 to power 323 formula units of sodium chloride. Now the linking the mole and the atomic mass. 1 mole of any element is equal to the relative atomic mass of that element in grams. For example, one mole of carbon, that is, if you had 6.02 into 10 to the power 3 atoms of carbon in your hand, it would have a mass of 12 gram. So 1 mole of helium atoms would have a mass of 4 gram, lithium 7 gram, etc. For a compound, we add up the relative atomic masses. So 1 mole of water would have a mass of 2 into 1 plus 16. It means 18 gram. Hydrogen, which has an atomic mass of 1, is therefore equal to 1 by 12 the mass of a carbon atom. So 1 carbon atom has the same mass as 12 hydrogen atoms. The mole and the volume of gases. Molar volume. This is the volume that 1 mole of any gas, be it molecular such as carbon dioxide or monoatomic such as helium, will occupy. Its value is 24 decimeter cube or 24,000 centimeter cube at room temperature and pressure. Calculation involving gases. General equation: amount of gas in mole equal to volume of gas in decimeter cube divided by 24, or amount of gas in mole equal to volume of gas centimeter cube divided by 24,000. So calculating the volume of gas that a particular amount of moles occupies. Equation: volume of gas in decimeter cube equal to amount of gas mole into 24. So you can see in this particular slide the name of gas, amount of gas, volume of gas: hydrogen, carbon dioxide, oxygen, ammonia. So these are the name of gases. Amount of gas is 3 mole, 0.25 mole, 5.4 mole and 0.02 mole, and the volumes are 3 into 24, 72 decimeter cube, 0.25 into 24 equal to 6 decimeter cube, 5.4 into 24,000, that will be equal to 129600 centimeter cube, and 0.02 into 24, that is equal to 0.48 decimeter cube. Now calculating the moles in a particular volume of gas. So this is the equation. Amount of gas equal to volume of gas decimeter cube divided by 24, or amount of gas in mole, volume of gas centimeter cube divided by 24,000. So you can see in this particular slide the name of gas, volume of gas and mole of gas. How to convert. Calculating reacting masses, solutions and concentration of solution in gram per decimeter cube and mole per decimeter cube. So you can see in this particular slide how to convert. Now calculating the moles. Amount in moles equal to mass of substance in grams divided by mR or AR. So you can see the example: substance, mass, mR, amount. Substances are NaOH, sodium hydroxide, calcium carbonate, H2SO4, H2O, and mass of these substances 80 gram, 25 gram, 4.9 gram. And you could say how to convert. Calculating mass. Equation for mass is mass of substance in gram equal to moles into mR or AR. So you can see in this particular slide how to calculate the masses of different substances. Calculating relative formula mass, and the equation for calculating relative formula mass is mR or AR is equal to mass of substance in gram divided by moles. Example: 10 moles of carbon dioxide has a mass of 440 gram. What is the relative formula mass of carbon dioxide? So relative formula mass equal to mass divided by number of moles. So the mass value is 440 gram. Number of moles are 10. So 440 divided by 10 equal to 44. That is the relative formula mass. Calculating percentage composition. How to calculate the percentage composition? Is found by calculating the percentage by mass of each particular element in a compound. Example: calculate the percentage of oxygen in carbon dioxide. Step 1. Calculate the molar mass of the compound. So molar mass of CO2 is twice into 16 plus 12, that is a 44. Step 2. Add the atomic mass of the element required, as in the question oxygen having atomic mass is 32, 16 plus 16. Calculate the percentage. So percentage of oxygen in carbon dioxide equal to 32 divided by 44 into 100. So that is 72.7%. Now the calculation of solutions, moles, concentration and volume. General equation is concentration mole per decimeter cube, amount of substance in mole divided by volume of solution in decimeter cube. The general equation is rearranged for the term as is asked in the question. Calculating moles. Equation is amount of substance in mole, concentration into volume of solution in decimeter cube. So example is calculate the moles of solute dissolved in 2 decimeter cube of a 0.1 mole per decimeter cube solution. So concentration of solution is 0.1 mole per decimeter cube and volume of solution is 2 decimeter cube. Now the moles of solute equal to 0.1 into 2, that will be 0.2 mole. The decimeter cube above and below the line cancelled out. So amount of solute is 0.2 mole. Calculating concentration. For equation for the calculation of concentration mole per decimeter cube amount of substance in moles divided by volume of solution in decimeter cube. 25 centimeter cube of 0.050 mole decimeter cube solution sodium carbonate was completely neutralized by 20 centimeter cube of dilute hydrochloric acid. Calculate the concentration in mole per decimeter cube of the hydrochloric acid. Step 1. Calculate the amount in moles of sodium carbonate reacted by rearranging the equation for amount of substance in mole and dividing by 1000 to convert centimeter cube to decimeter cube. So amount of sodium carbonate equal to 25 into 0.050 divided by 1000 equal to 0.00125 mole. Step 2. Calculate the amount in moles of hydrochloric acids reacted. 1 mole of sodium carbonate reacts with 2 mole of HCl, so the molar ratio is 1:2. Therefore, 0.00125 moles of sodium carbonate react with 0.200250 moles of HCl. Step 3. Calculate the concentration in moles per decimeter cube of the hydrochloric acid. 1 decimeter cube is equal to 1000 centimeter cube. Volume of HCl equal to 20 divided by 1000, that will be 0.0200 decimeter cube, and concentration of HCl, that in mole per decimeter cube, will be 0.00250 divided by 0.0200, that will be 0.125. So the concentration of hydrochloric acid is 0.125 mole per decimeter cube. So this is all about the today's lecture. Thank you very much. Goodbye.